For a stack, I would use a linked list where the head of the list represents the top of the stack. When I push, I add a new node at the head, which is labeled O1. When I pop, I remove the head node and return its value, which is also O1. Get top just looks at the value stored in the head node without removing it. So the O1, so that would be O1. Is empty checks whether the head is null, so that is O1. For a queue, I would use a linked list where with both head with both a head and a tail reference. The head represents the front of the queue and the tail represents the back. When I enqueue, I add a node at the tail, which is O1. If I keep a tail reference, when I dequeue, I remove the head node and return its value, which is O1. Size can be O1 if I keep a count variable that updates whenever I enqueue or dequeue. Is empty checks whether the size is 0 or whether the head is null, so that is O1. Overall, linked lists work well for stacks and queues because they allow adding and removing from the needed ends efficiently without shifting elements like an array might require.